we are thrilled to present this tutorial of vocabulary techniques in ETL. Like, what things do you need to know to run the ETL, right? And I'm happy to work on that with this very nice team. And we're going to present from the very beginning, like, what is the source concepts? Why do you need mapping? And then we're going to talk how to store the mappings. And then if you want to, even distribute it for a broader community, we also will give you the way how to do that. And also, we are going to talk about the future. What are the improvement and what are the emerging standards? So I will start from, what is the concept mapping? In source data, it can be, the same term can be written differently. And of course, you can't query all those different variations. Here are just 4, but there are much more variations in different vocabularies, different ways of medical notes written. And that's why we decided that in Odysseus standardized vocabularies, we have only one concept for one clinical idea. And this concept goes standard, right? So we build relationship from all this stuff to one standard concept. And it's used in work as maps to relationship in concept relationship table. Then, so now you know what mapping is. And the next question is like, okay, how do I do mapping? What are the principles? First is you need to use standard concepts. Then you have to be consistent, domain consistent. For example, calcium in labs can mean calcium measurement, while if calcium is written on a drug administration table, it can mean a calcium, some kind of calcium injection, right? Also, when you map, you don't spend time mapping some useless concepts, like documents reviewed. Like, what documents? Like, how is it? Which insight can it give it when you do the actual research, right? So when you do mapping, you think how this concept can be used in the actual research. And if equivalent mapping is not possible, then you can map to a less granular concept, or even you can map to 2 concepts. In this example, this concept, like, there is no target concept that says respiratory complication and first trimester. And then you can map to both to 2 concepts. So in your data, 2 rows will appear. And then whatever research, people with pregnancy or people with respiratory disorders, both will appear in your search, in your cohort, right? Then the next question is like, now you know what mapping is, you know how to map, and then the question is, what do you actually map, right? And so in your data, there can be concepts, right? It can be codes. There can be codes and vocabulary ID. Vocabulary ID which exists in Athena. In this case, you identify the pair of the code and a vocabulary ID, and then you map this source concept using concept relationship table, using maps to and maps to value relationships to get to target concepts. So this example, it's ICD-9 or ICD-10 concepts, and with concept relationship table, you get to target concepts. Another scenario is when there is a vocabulary in your source data, so you can see here the codes, names, and some metadata also is present in this vocabulary. But this vocabulary is not in Athena. If you just type in 8850569 in Athena, you will not see superficial skin infection, okay? So in this case, you do the following. Sometimes this data can have hints. For example, this vocabulary has links to ICD-10 concepts. So you go from standard code from that vocabulary to ICD code, and then use the previously discussed idea. And then you map ICD codes to SNOMED, or whatever target concept you have, and get the mappings. Or there can be another case when the source vocabulary, source ontology doesn't have hints. Then you need to do the lexical match, right? And third scenario is when you don't have codes or don't have ontology, you just have text entries. mostly it's a derivate from NLP, like medical notes were processed through NLP, and then they get some abstraction, right? And usually it's just one row. You will see lab name, lab test name, or disease, right? But here I bring this example because it's a little tricky, because cancer diagnosis is made out of three components: direction, neoplasm time, and histology. And you get right mammary carcinoma, which is legit diagnosis concept, right? So I specifically give this tricky example because to highlight how important this is, how important to review that, because all other steps we will talk about in this tutorial will depend on that step, right? Like how you define this thing. If it's ICD-10 or ICD-10-CM, we need to know if it's US data or non-US data. Okay, anyway, so yeah, so what do you do next? You get this right mammary carcinoma, and then you do lexical match. And one of the best, one of the most used tool in Odyssey is Usagi. And let's quickly overview what Usagi does. So it's easy to find Google Usagi Odyssey, and then it gives you the first page with that quick short overview, and then you click that thing, and it's a very nice article. It's a long one. Also, it says it's not updated. It's really good. It's recommended to read if you want to use Usagi. And then once you get there, you install it, download and unzip the Odyssey vocabulary. Then it will ask you to build an index using this vocabulary, and then you import source codes and map them. I don't spend much time on that because you have nice documentation, or you can run it and it's pretty intuitive. Then you import codes, you choose your file with source codes. You can see there are codes from that example of this cancer, right? So you assign source code, source name, source frequency, because the more frequent concept is used, the more time you want to spend on that. You want to prioritize concepts that are frequently used, right? And imagine you don't know what it is, what it means, and you click import, and it does the mapping for you. And then it just looks at words, melanoma, and finds melanoma, lymphoma, it finds lymphoma. But if you don't specify which domain, remember one of the principles was domain consistency. If you don't specify domain, it will find you melanoma as an answer. Because there was some question like what cancer, which cancers did you have or whatnot, and there was an answer. Or morphological abnormality, like part of histology. So this is not what you need, because we have diagnosis table with cancer conditions and unit conditions, right? So then you have this magical filters. You can click this and choose condition domain, and you can click this and choose vocabulary. Right? It's probably just enough to choose domain, because no other cancer diagnosis sit in any other vocabulary than ICD-10 and stomach. But you can choose this as well, and then the result is much better. You see condition, disorder, all those types of neoplasms and stuff. And then the first recommended thing is to order by match score. It means like how similar the name in source is in the name in target are. And here you can see adenocarcinoma is malignant adenomatous neoplasm. It's different names, but synonym is the same. This is adenocarcinoma. So you can, if you have domain consistent match and match score 1 or very, very high, you can just select those concepts and approve them. Approve that mapping is good, right? Next thing you do is sort by frequency, and let's see how to map the most frequent concept here. So here's an overall user interface of Usagi, where you can see in the top the list of mappings, and below the suggested concepts for this highlighted concept. Right, so here is a raw. The mammary neoplasm maps to mammary, paramammary lymph nodes. Let's choose correct concept. So look here, and you see like this closest one is primary malignant neoplasm of breast. But remember other principle, you don't map to more granular concept. This says just mammary neoplasm, and here says a primary malignant. It can be benign, right? So you need to find the mammary neoplasm. And if you don't see it here, you can type in here. And you have this, you have even neoplasm of breast, the one you need, right? And you have screen and you have skin status. And then again, there's this magical filters. If you filter by domain, here is your only types of breast neoplasm. And obviously you choose this one because it's the full equivalent of that thing. And once you approve your concepts, you can create file export source to concept map. You can create source to concept map, which has all those links between my source concepts and targets. And I will, and Tanya will talk about this way how to store concepts, sort the concept map, and other ways of doing that. Tanya?
Yep, thank you, Dima. So let us continue with talking about what you do when you already have your mappings. And by mappings, I mean connections from source entities to some standard target concept IDs. So you need to use them, you need to store them in the CDM somehow. And today I will be talking about two main approaches that we use, and you may already be familiar with some of them or all of them. These are source to concept map table approach and concept relationship tables approach. Source to concept map table approach is the one that Dim has just said is being directly exported from Usagi, so that's an easy thing to do. Today, I will be really relying on a poster by Melanie from some years ago. The link to it is on the slide, so if you want to refresh your memory or just have something to look at, you can go there. So let us start with the first scenario, that is source to concept map approach. And let us use the last example Dima has mapped, that is memory neoplasm to neoplasm of breast. So the basic structure of a source to concept map table is presented here on the slide, and it basically stores both your source entities and their mappings to standard concept IDs. We can call it a sort of a lookup table for your mappings. It is designed so that you can easily add mappings to it and remove mappings from it. Please note that wherever source entity you're mapping is presented in this table only as a source value or a source concept ID, depends on the data. So if your source code does not find a mapping for some reason, for example, it doesn't have a match in vocabularies for some reason, you will not be able to share it and use it in shareable standard tools such as Atlas. One other thing to note about source to concept map table nuances is that by default, we consider that it uses only one type of relationships, and that is a maps to relationship. Sometimes you may need to use, for example, a maps to value relationship, which can be useful in cases when you're mapping measurements and their results. And we'll be talking about how to do that with the second approach a bit later. So Dima, may I ask you to show me the second scenario slide? And that is, if we were trying to map the same memory neoplasm source code through the concept and concept relationship tables. So you may be already familiar with these tables. They are basic tables of the CDM that store concepts and their relationship to other concepts. And concept table helps you store only your concepts without any relationships they have. So what you would do, you would add records to the concept table for each source entity that you have, and the machinery will assign 2 billion plus concept IDs to them, basically making them custom concepts, what we call, same as any other concept in the Athena you may have seen. By default, we recommend making them non-standard. That is, the standard concept field will be null. There may be corner cases when you can make them standard, but we really advise thinking about that because there may be some unexpected circumstances. You need to assign concept classes to them, domain IDs. So what you're doing, once again, is modifying concept table of the CDM a bit to accommodate for all the source entities, custom concepts that you need to add. These 2 billion plus concepts, as we call them, they will be usable with your fellow network researchers. They will be visible in Atlas and other tools, even those that do not have a mapping, once again, because they are still considered concepts. And that is a good thing. And regarding the point about different kinds of relationships, this can be accommodated by the concept relationship table. So you have stored your concept in the concept table, and now you need to store your mapping somewhere. And for that, we use concept relationship table. Once again, you add mappings for your custom concepts in there. So here you can see that we have a direct that is maps to the first row and reverse mapped from second row mappings of our custom concept of memory neoplasm to a standard concept ID of neoplasm of breast. And you can see that here, since we have a specific field called relationship ID, you can put different kind of relationship IDs in there. One of them may be maps to value, which once again, as I said, can be useful with measurements and their results. And same as concepts, such relationships, they can be visible in Atlas, they can be shared. So that is a really good and useful thing. And now I can offer you to sum up what we talked about here in this table. So once again, we have two main approaches, two most widely used approaches to ETL. These are source to concept map approach, or STCM, and concept relationship tables approach. The first one is creating a mapping inside a sort of a lookup table, which is designed for easy insertion and removal of records. The concept table approach is a bit more tricky in implementation since it requires you to modify tables of the CDM a bit. However, there are several pros to it. For instance, unmapped code which will still be visible there as custom concepts without mapping. You can also use maps to value relationships in concept and concept relationship table approach, and you cannot do that in STCM approach. STCM table requires additional querying, since once again it's an additional table. And concept relationship tables allow you to look up your concepts as well as any other OMOP vocabularies concepts you could search for. So in general, we can say that STCM approach is a bit less usable in a large-scale network studies when you want to share your concepts. However, it is really easy to implement. It is directly exported from Usagi. And this is why when doing research on your own locally, it may be really a good thing to start with. And concept relationship tables approach is a bit more complex. It requires some additional procedures with modifying the tables, but its results are shareable, usable in network research with your colleagues. And speaking of networking and sharing things, let me pass the microphone to Anna, who can talk about collaborations and contributions.
So now you mapped everything, you feel good, but also you want to share all of the exciting work you've done with the community. You want to help your other community members to do the same work you've done, or maybe you want to do a network study or something like this. And when we think about sharing your work with the community, there are essentially two use cases. First, on your left side, is the first use case where in your source data, you have structured vocabularies. And this refers to what, in fact, Andy has been asking in the chat, is that if you have a vocabulary, you can recognize it by having some sort of structure, having source codes. So you have the explicit codes of whatever format they are, and usually you have an external reference. So there is a website that describes this ontology. There is something you can cite. And you have an example of ICD-10 Australian modification as one of the vocabularies that are not in Athena, but you can find it in your source data if you work with this vocabulary. The second use case on your right side is where you truly have the collection of free text strings. And that's common for EHR data sources, for flow sheets, for lab tests. In that case, you really have a collection of strings. You don't have codes. Usually the names are poorly standardized and you have no reference. And of course, this is not a formal definition of vocabulary. This is just a simple way of framing the distinction between a vocabulary and free text terms. And now on the next slide, I will first tell you what to do with your free text strings and the mappings. So if you have them and you want to share them, and in fact, we do have a couple of community members that wanted to share their mappings, which we're very thankful for, then you would go to Melanie. Melanie leads what we termed, roughly speaking, mapping knowledge base initiative, where we work together also with Tufts and other collaborators on establishing principles and environment on how we will store this mapping so that they're reusable, so that everybody can go to a certain interface, download the mappings and reuse them. While that is in progress, what you can do is you can in fact reach out to her, and either if you want to collaborate on the project itself, you are free to collaborate, but you also can simply contribute your mappings, and that's already will be a tremendous help to your fellow community members who will be able to reuse them. Now, on the next slide, I will talk more about what you do if you have a true source vocabulary that has codes, that has external reference. In that case, you can contribute it to the community and it will be accessible through Athena. That will also help you in your pipelines as well, because now you will be downloading all of the content from Athena. And this contribution contains of two parts: contributing the vocabulary itself, codes and names, and also the contributing the mappings that you created. And this QR code will lead you to the templates and to the documentation that we built that actually guides you through the whole process. And on the next slide, you will see the pipeline of this community contribution. You will start with the issue on GitHub, on Vocabulary GitHub. You will fill the templates with your content. We will review it for the purposes of the structural checks, and then it will end up in the release so that you and others can download it. And my next slide will show you a simple example of the templates just to give you an idea of what it is. Essentially, what you have in front of you is two spreadsheets from one template. The template is called Template for Adding Vocabulary, and that template has everything you need to add a vocabulary. The first spreadsheet is a concept manual table, and it's very similar to what Tanya showed before with the concept table. And essentially, this is where you would place information about your codes: concept name, concept code, your vocabulary, your domains. It does require you to figure out the domains and classes, similarly to what Tanya showed before, but of course, we are there to help you. The next spreadsheet here is the concept relationship manual, which is very similar to concept relationship, and this is where you store your mappings. And as opposed to Tanya's part, you don't need to create bidirectional mappings. You just need to create a maps to relationships or maps to value. And there you would simply put your source codes, relationship maps to value, and you target vocabulary, and you can choose from filling concept IDs or concept codes. But again, both of these spreadsheets are very similar to the existing vocabulary tables, and therefore they should be rather intuitive. On the next slide, I will show you another important piece that we started to implement last year, which relates to the metadata. In the concept relationship manual, we also have additional fields to collect the metadata elements about how confident you are in the mappings, which will be important for those who reuse them. Whether you think the mapping is precise or maybe it's uphill or downhill, we as well collect other things such as where you got those mappings from and how you validated them. And these metadata elements are coming from the CSAM model that we extensively collaborated on use of it with, again, Tufts and Nico and other people. And those metadata elements are used in the vocabularies as well. What is more interesting is that in the Usagi part that Dima talked about, we also are striving to get the same name in there as well, so that when you do mappings with Usagi, you will be able to also collect this metadata elements and record them in the same way, so that we have the structure unified throughout the Odyssey community. And this piece is important because, again, that this piece will tell everybody else on how confident, how good, and how validated those mappings are. And in general, I would like to conclude my part by saying that we welcome those contributions a lot. We do have people who contribute, and we hope to see everybody else who have their mappings and vocabularies contribute back to the community so that others can reuse it. And with that, we're moving on to Alexander's part, who now will talk about the future of using vocabularies for ETL.
Thank you, Anna. Okay, the team has shown you what the current approach is. You should use it if you have some data that you want to map to OMAP CDM. But we've been doing this for more than 10 years, all the same way. Being in the global community that constantly grows, we also need to be more efficient and we need to scale up. So I'll show you a couple of things that would allow us to go beyond. Some are already available and we suggest you to use them, even if you do some small detail in your shop. Others require more investigation and work needs to be done, but we're working on them and encourage people to join. The first problem relates to the mapping of other data types. Other than using claims or EHR, vocabulary mapping is straightforward. If your source is a cancer registry with stages, survey instrument, or other entity attribute value type of data, it's not going to be easy. Get ready to do gymnastics on structural mapping, build complex expression with pre-coordination, and custom map them. You know well the list of the issues. No time to go into the details. Look at the use case now and take your time and look at the rest later. It might seem geeky and the problem is not on the surface. People probably think that they are all fine with all the shortcuts we use at the moment, but it actually adds to the technical debt that we collect over the years. So we need to fix it. Here is one of the solutions, the wide mapping table. This is one table. It includes a full set of fields that we map to. It's not only the content, but it's also the set of machine-readable instructions for ETL to optimize it and make it easy. You can find the full text here with the QR. Come to the working group. We will be discussing this at some point. The next thing is the Common Data Environment, or CDE. Look at the problem we need to solve. Dima correctly pointed it out on the GitHub. The idea is very simple, to keep in groups the concepts that have identical or similar meaning. When they're bound together, you're making the mapping decision once for the whole group, and then everything is obvious. If you have related terms, they're close to each other, so you actually see and control the mapping decisions. It enables mapping alignment and ease mapping reuse between vocabularies or data sets. So you don't need to be in charge of the huge collection of data sets to find it useful. If you have 2 data sets of the same origin in your pipeline, it's already enough to start using this and get the benefits. This is how it works. You load in the data sets into the environment as 1, 2, 3. Then you define the rules and criteria for grouping. Then the machinery applies the recursion to make sure that you don't lose any standalone concepts and the bigger groups are merged. Look, these concepts are linked to each other. Then you do the mapping job and pull the results back to the original data source. That's it. So this is an example on how related concepts end up in the same group. You have one consistent mapping, and you don't need to do it over and over again. We will be sharing this more during the European Symposium. The metadata. Pretty much what Anna has shown you. This is what our friends Nicholas and Palina have brought to OMOP. At the moment, we introduced 2 components that we believe are useful for mapping representation in OMOP, the confidence and the predicate. Confidence tells you how, who, and by what way generated the given mapping, whether it's an automated mapping produced by the machine or taken from some external source, or you look at the full semantic match done by the medical terminologist, that is justified map. Predicate is the approach to characterize the mapping, whether it's the full equivalent or uphill that goes up the hierarchy to more general term, or down the hierarchy to more specific term. So this example goes up, this goes down, and this one is good. We've done it for MADRA. All the mappings to standard terms were annotated, and it appeared that 5% of them interfere with the hierarchy. And it's really important because MADRA is like a parallel world to SNOMED, so we have to be precise. It helped us to align MADRA to SNOMED hierarchy and put it into the single hierarchy. So this one you can see on the slide here. You should also do that. We enabled this with the community contribution. We're moving towards adding this to SAGI, and please use it. The last thing I'd like to talk here is the AI revolution and what does it have to do with the vocabulary tasks. Indeed, we're greatly struggling with the problem. We have lots of manual work and it ain't getting easier. It requires highly trained people with a unique combination of medical and terminology knowledge, so we need to optimize it. This is the obvious space where machine learning should be helpful, right? It looks like a trivial application, isn't it? Everybody believes that. Probably each of you tried to ask ChatGPT the mapping questions. So we also tried. We've been playing a lot, I tell you. But there is no solution on the market. Why not? Because it's not that easy. It's not just the surface representation, it's the reasoning. Machine cannot do that. We're in the very specific domain. And it's very heterogeneous. It's moving. The carpet is moving while we're standing on it. And it's a lot. We are, the Odyssey, have the largest mapping repository in the world, but it's still a lot, even for us. If somebody tells you that it's easy, my group does it all the time, so I know what I'm talking about. We're not done yet, but let me show what we have done. This is a tool set we can effectively use to address the task. For quite some time, we only used first 2. Classic way to do that is by using a SAGI. Dima showed it to you. But then we have to balance between the near 50% level of accuracy that Usagi provides and manual mapping and the review work that is done on top. But apparently we should nail the problem with other tools. It looks like the mapping is the same, but it's really different. If you've done your ETL, you probably know they're all different. Controlled vocabulary that are done using some rules. And there's some free text that you get during the ETL with the junk, abbreviation, jargon, and things like that. And there's a complex term. We call them this way. Look at them. Can we map them? Okay, look how it looks like. Here are the numbers, the accuracy. It's pretty depressive. I want this to be in the high 90s, so I actually can say that the problem is solved. Osagi is good overall, but not for the complex one though. Then using the newer models, we can improve. And look at this. AI doesn't actually improve it. Not for all of them, but for some of them, it doesn't really help. It's too smart for us sometimes. And now, as you saw in the previous slide, combining the methods improves the overall accuracy. And the main problem is the assessment if something is good or way off. We are now doing more experiments with combining the components in different ways. Each time we will check what the problems are, and if we can predict a problem appears, we will treat it differently. In other words, we dissect the problem to its main components and create an optimal workflow. But the overall goal stays the same. Map things over the weekend instead of fix of experts as is done at the moment. I think we're in time. That's it. Thank you for joining.